Welcome everyone. In this video we're going to cover problem number 6 on the chaotic review. The claim is this problem actually has a long way and a short way in order to evaluate it. So I'm going to go over the short way with you. The long way is just to actually evaluate the expression that's given to us here. Right? We can actually do this. We've had some practice, but this reminds us, right? Even when we look at this reminds us of the definition for this Riemann sum thing, right? The original definition of a definite integral, right? When you wanted to calculate this thing out, right? You had some f of x sub I times a delta x. You added up the areas of a lot of rectangles, and then you took the limit as the number of rectangles went to infinity. So actually, this is the definite integral of something. Right? So let's actually take it in that direction, right? Because we can actually calculate out definite integrals quite quickly. So I would like to go ahead and maybe rewrite this. We're going to have the limit as n goes to infinity, summing up from I equals 1 to n, and I'm hoping that this is some g of x sub I times a delta x, right? A height of a rectangle times a width of a rectangle. And if that's the case, the claim is, again, this was the original definition for the definite integral between a and b of now g of x dx, right? Because we have the g function here rather than just, right, an f function. So, okay, it would be the integral from a to b of g of x dx. And so actually, right, I have the g function right here. It's x squared minus 1. So this is going to be the integral from a to b of x squared minus 1. And now we know how to evaluate this quite quickly, right? We can use the fundamental theorem of calculus, which says, hey, take the antiderivative, plug in b, subtract away when you plug in a, and then you're done, sort of deal. So we can actually evaluate, and this will be the fast way. The only question that I have is really, what should this a value be, and what should this b value be? And so this really requires us to dive in a little bit to what is the definition of this delta x, or how can we express this, and likewise the x sub I. So I'm going to remember here that delta x was the same thing as b minus a over n. b minus a over n. So in our case, delta x looks like it should be 3 over n. So this should be 3 over n. So we could do a little bit of cancellation, and we'd get b minus a should be equal to 3. Or another way we could write that is that b should be 3 more than a. So if you take a and you add 3 to it, you should get out b. This unfortunately doesn't help us determine uniquely what a and b are, right? But this does give us a relationship between a and b. Okay, so how about this x sub I business, right? Because we also have that, hopefully the thing that we're plugging in here is x sub I. So remember, x sub I is supposed to be equal to a plus I delta x's. That was the formula for x sub I. So a plus I, and my delta x in this case is 3 over n. 3 over n. Now again, in our specific situation, we have 1 plus 3i over n. So 1 plus 3i over n. And we can actually see, right, there's a 3i over n right here, and a 3i over n right here, so those will perfectly cancel out, and we're going to be left with that a should be equal to 1. So if a is equal to 1, then when we add 3 to it, we can get our b value, so b will be equal to 4. So we can actually see here that we can solve this problem by integrating from 1 to 4 of x squared minus 1 dx. So now let's take the antiderivative. I'm going to get 1/3 x cubed minus x, and then I'm going to evaluate from 1 to 4. So when I plug in 4, I'm going to have, let's see, 64/3 minus 4, and then I'm going to subtract away when I plug in 1. I'm going to have 1/3 minus 1. So let's see, 64/3 minus 1/3, that's going to be 63/3. And then I have negative 4 minus a negative 1. So that's going to be negative 4 plus 1. That's going to be minus 3. Now 63/3 we can actually evaluate, or we can simplify down a little bit farther, right? That should be 21 minus 3. And so altogether we get the final answer of 18. So again, by remembering that this is the same thing as a definite integral, we can actually evaluate this out quite quickly because we have a lot of skills in evaluating out definite integrals. However, again, there is a slow way. If you just straight up evaluated this, you'd have to plug in 1 plus 3i over n into g everywhere you see an x. So you'd have to square that, you'd subtract away 1. Then you'd multiply by 3 over n. You would sum up, right? You'd have to use rules of the sigma notation. And then you would take the limit as n goes to infinity, right? So that was like a section 3.4 topic, all of these limits to infinity or horizontal asymptote stuff. So again, there is a longer way that's a little bit maybe more straightforward, but if we remember this is the definition of the definite integral, then this is the slick way that we can evaluate it out. All right, thanks for watching, guys. I'll see you next time.